Okay, in this video, I'm going to discuss briefly on the intermediate value theorem and give a couple examples, okay? So what do you mean by intermediate value theorem? What it says is if a function fx is continuous in a closed interval a, b, and if the height of the function at a and height of the function at b are not equal, then for any number k between those two heights, there exists c between a and b such that fc equals to k. What does that mean? That means, suppose there is a function that is continuous between -1 and 11, okay? At -1 the height is +1, at 11 the height is 5. So the height at -1 and 11 are not equal, right? Now, for any height between 1 and 5, you will be able to find out the x values between -1 and 11. For example, at 2, if the height is 2, that 2 fall between 1 and 5, right? So what is the x value for that 2? Is 0. That 0 falls between -1 and 11. At 3, for example, at 3, the 3 fall between 1 and 5, right? At that time, the x value will be +2. You see that? At 3, the x value is +2. Okay? So at 4, this is 4, right? For if y is 4, if fx is 4, if k is 4, you can say, if k is 4, then the c value will be, is that 8? Looks like 8, right? So you can, so first, what does it say is, if fx is continuous between a and b, and fa and fb are not equal, then any number between fa and fb, between these two heights, you will be able to find out the x values there, at least one x value. There may be more than one, but there will be at least one c, or x equals to c, that fall between -1 and 11, okay? So fx is continuous on what? -1 through 11, okay? So for any value value k, for any value k between what? Between 1 and 5, between 1 and 5, you can find x, you can say between -1 and 11, so that fx equals to k. That's what the given by the intermediate value theorem. Okay, so for example, when k equals to 2, when k is 2, x is 0, right? When k is 3, x is 2. When k is 4, x is 8. So you are able to find out x values for any number k value between fa and the fb. Okay, let us do one more example here. Let fx equals to x squared plus 8x plus 2, and fx is continuous on 0 to 8. It is given, fx is continuous on 0 to 8 is given. Find c such that fc equals to 35. So we need to find out c such that fc equals 35. But the intermediate value theorem says that since the fx is continuous between 0 and 8, and what is f at 0? So solution, what is f at 0? F at 0 is 2, right? You just plug in that 0 here. And what is f at 8? F at 8 is 8 squared plus 8 times 8 plus 2. What is that? So that is 8 squared is 64 plus 64 is 128 plus 2 is 130. Okay, so what it says is, if you pick any number between 2 and 130, you will be able to find out that c. But here we are picking fc equals to 35. So we should be able to find out at least one x value between 0 and 8. Okay, so how do I do that? So f of c equals to 35 implies c squared plus 8c plus 2 equals to 35, right? Now you need to solve this. Subtract 35. Subtract 35. What do you get? You will get c squared plus 8c minus 33 equals to 0. Do you know what are the two factors whose sum is 8 and product is 33? Is that c squared plus, you don't have to do it. You can just write in the factor form directly. So it will be c plus 11 and then c minus 3. So the product is -33. The sum is +8, right? Equals to 0. So you can write c equals to -11. If you set that first factor equals to 0, you get c equals to -11, and then c equals to +3. But you ignore the -11, right? Why? Because you want to find out between 0 and 8 only. Therefore, this is the only answer you get. Okay, c equals to negative 11 is outside the range that the question is asked. Okay, the final example for this section is if fx equals to 8 minus x squared for x lesser equals to c, and if fx equals to x for x greater than c, find f, and fx is continuous everywhere, find c. So since fx is continuous everywhere, fx is continuous at c, so the left limit at c and the right limit at c, because this function is continuous everywhere left to c in the domain. This function is also continuous. These are the polynomial functions. They are continuous in their domain. But at c, it has the boundary, right? The boundary between these two functions, these two pieces is c. So we want to check at c only, because everywhere else it is continuous. So solution. So what is the left limit? For the left limit, x tends to c minus fx must be equals to limit x tends to c plus fx, right? Because the function is continuous everywhere, meaning the left limit and the right limit at all the points must be equal. So it must be equal at c as well. So at the left limit, you take the first piece, you get 8 minus c squared, although it is denoted by c minus, we plug in c. And then on the other one, you plug in just c, because x is replaced by c. So what do you get? You add c squared, subtract 8. Add c squared, subtract 8. You get c squared plus c minus 8 equals to 0, right? And you need to use the quadratic formula for that. So a is 1, b is 1, c is negative 8. So if you do that, c equals negative b plus minus root under b squared minus 4ac divided by 2a. Now plug in that a, b and c, you will get negative 1 plus minus root under b square is 1 square minus 4 times 1 times 32. That will be 33, because 1 plus 32 over 2. So these are the two values of c. Okay, these are the two values of c that makes the function continuous at c. So c equals to that is the final answer, plus 1 plus root under 33 over 2, and then negative 1 plus root under 33 over 2, and negative 1 minus root 33 over 2. These are the two possible values there. Okay, that makes the function continuous at c as well. All right, guys.